Hello everyone, I'm the engineer Vaccaro Davide, and what we are going to talk about in this short video is the Sismosprink software, the first non-mirror software dedicated to the sizing of static and seismic supports for both sprinkler and hydrant fire networks. As soon as we open the software, we can see an user-friendly interface of the program structure that contains all the design steps within a tree menu consisting of 4 nodes. To create a new project, simply go to File, New, Sismosprink document. The first design step consists in choosing the initial design parameters, and this is made possible thanks to the Classification tab. Within this we can choose the type of verification, the type of system to be verified, the reference standards, the base material and the location. The latter is simply chosen through a map that uses the GIS system to determine the seismic parameters relating to the selected place. Returning to the regulation, the standards that regulate anti-seismic verification are UNI, FM and NFPA, and each of them requires parameters that are used to be able to arrive at the determination of the final loads acting on the supports. While some of these parameters are project parameters and therefore very simple to calculate, others are decidedly more complex, but Sismosprink comes to our aid because it's able to calculate them automatically using the parameters of the location chosen in the map. In the second node we will instead insert all the pipes that appear in our project. Also in this case Sismosprink comes to our aid because it offers us the possibility of directly importing the tube from the archive, which includes dozens of models, using the following option, with which it's sufficient to simply select the model, click import and choose the diameter and the category. We therefore arrive at the plans node, which represent the very heart of our project and which contains within it the types of verification and the plans that we have previously chosen in the classification window. The result of this node is the determination of the design load acting on our supports, but this requires the insertion of some parameters. Very simple to enter in the static case, slightly more complex in the seismic case, but Sismosprink guides us in every step along all the passages, also thanks to the numerous aids that we find in correspondence with this icon. We will then be guided in the insertion of the length of the zone of influence, geometry of the braces, presence of branches, and finally, in the last window, we will find the calculation of the design load acting on the braces. Once we've obtained the value of the seismic calculation, we designers should go and choose the suitable components for numerous catalogs. This Sismosprink is able to do it automatically and in a few moments, because it contains within it, in the basic archives that we find here above, dozens of models and categories of the components that are part of VLT Collection, a manufacturer of static and seismic support with which Namira collaborated for the creation of the software. Sismosprink therefore compares the design load obtained with the resistance of the components and consequently chooses the most suitable pieces. All these components are reported in the last node, calculation result, which is divided into calculus, which reports the components for each typological, and computation, which instead represents a list of all the pieces we will need. At this point, Sismosprink allows us to export 3 types of documents: technical information, verification report, and technical report, which contain reference to the standard use, the detail of the calculation, and a detailed material list complete with diagram of the supports. Finally, Sismosprink gives us the possibility, by clicking on the Export DXF function, to be able to see our supports both in 3D view and in projection on the various planes, and to export these diagrams in the XF format using the button below. As you can see, this was Sismosprink, a software as simple as it's powerful, which allows us to design our support, saving a considerable amount of time and avoiding errors due to the human's hand. That's all for this video, thanks for your attention and see you soon.